Hello everybody, thank you for joining us today, and as advertised I will be giving you an introduction to Neo4j. So what I will be covering in today's session, I will be providing a brief overview to a property graph database. I will provide an overview of Neo4j the company and our graph platform. I will walk through some of the graph use cases that we have, and I will also provide another brief session on Cypher and the Open Cypher project. I will also would like to provide an overview of GraphTour 2018, which will be taking place in cities across Europe and the US. And as Angelica mentioned, I would like to take some of your questions at the end. So, as I'm sure all of you are very aware, we are seeing an exponential growth of data, and the kind of data that's being generated, so human and machine data, be that through messaging, social interaction, capturing of location data and so forth, is significantly growing faster than traditional data that would have been captured on various data sources. And having the data alone, this huge volume of data, can't be used to its fullest potential until we start thinking about how that data is connected to provide insight. And as you can see on the slide, we've got some examples here. So networks of people, you want to understand how people are connected to people. Business processes, you want to understand what kinds of things people are buying and the relationship between those contexts. And also things like risk management. So if there's a faulty issue with a product or a service, who does that impact? And knowledge graphs as well. This is a big growing area, and you want to be able to understand how to search the information and collateral you have already and use it to its fullest potential. So I'm going to give a brief overview of what a property graph database is, and we're going to start with the nodes. So the nodes, as we've got here, we've got a person nodes, we've got a car node, and a node, or in graph theory also referred to as a vertex. These are your units of information, and they're typically thought of in a verb. So a verb typically is a node, and we can also apply labels to them. So what we've done here, we've got a person label on these two nodes here, and we've got a car label on this node here. And that effectively gives us an opportunity to be able to filter groups and subjects. And you can have multiple labels on nodes. For example, with the car node here, we could also apply an asset label to it if, for example, we wanted to be able to understand the value for insurance purposes. So, following on from that, we also have relationships. So again, looking at graph theory speak, a relationship is also referred to as an edge. And with these relationships, we connect the nodes and we start to build out the model and get an understanding of how these units of information relate to each other. We also have directions on relationships, and the direction is important if you want it to be important. So, for example, if we're representing hierarchies of information, then we may be interested in knowing whether a node is higher up to another node. So, for example, a manager to an employee relationship or an ownership relationship. So as we've got in the diagram here, the person on the right owns the vehicle rather than the vehicle owning the person. But again, we can ignore the direction in the relationship if that's not important, and that's also commonly used. To further enrich our model, we can now apply properties to our nodes and to our relationships. So, for example, for the person node on the left, we've now given the property with a name, and it's got name of Dan. That Dan has a birthday, so again we add that property. He's also on Twitter. And a powerful thing with Neo4j is if there isn't a property, we don't need to add it. So for example, the person node on the right, Anne, isn't on Twitter, so we've not added a Twitter property on there. But if it's required for your project, then there are versions where we can enforce the use of properties. So this gives you a huge amount of flexibility to grow your model as you get more and more information in. So, for example, of the model here, if we decide we want to grow out other assets that they may have, so for example, a house, a residence, or a second vehicle and so forth, we can keep adding these nodes in and the relationships that join them and any relevant properties as we go on. And a phrase you will commonly hear from us, that graphs are everywhere, and they really are everywhere. And I've got some examples here up on the screen. So for example, organizational hierarchies beautifully lend themselves to graph. You can start to get an understanding of who is managed by who. And a really powerful thing as well is that we can add additional relationships. So for example, if there is a dotted line relationship, so a project manager looking after a specific project team, we can add that flexibility and build out the model. Equally, if we want to start grouping into teams or specialities or organizational domains, again, that's something we can really flesh out and grow and make the model relevant. Social networks. What's really powerful, especially within a social network, is it's great to understand who your friends are, but it's really powerful to know who the friends of friends are. And this is how we network and work well, and being able to represent this and understand the connections. Again, fantastic use of graph. Product subscriptions. Being able to understand who should have access to what, who's paid for what. Again, a very powerful use case for graphs and how it's being applied, and making sure that you can easily understand who needs to have access to something and when to turn it off when the customer leaves. And network operations, being able to have that power to understand how various parts of the components in the network connect together, and understanding potential points of failure and root cause analysis, again, lends itself extremely well to graph. So I'm going to talk a little bit about Neo4j, the company. So we are the creators of the graph platform. We have around 200 employees, and we're based in San Mateo, but we also have offices in Europe as well. And we are the market leaders in graph databases. We have had over 10 million downloads. We have a lot of big enterprise customers and a huge level of adoption, as you can see there. And we have some really high profile customers using us. And I will shortly go through some use cases with some of the customers, and absolutely, please do go on to our website, neo4j.com, where you can have a look at a lot more customers and how they're using us. So we are the graph technology pioneer. We started releasing our first generally available version of the software in 2010. And we've done some amazing things along the way. So, for example, in 2012, we released the definitive book on graph databases. And again, I would like to flag here, it is a fantastic book, and you can get a copy of the second edition for free if you go onto our website. And I do heartily recommend that. It will cover things from data modeling to best practices. Also, in 2015, we started the Open Cypher project, where we open sourced our graph querying language. So I will talk a bit more about Cypher and do a brief introduction to it later on in the talk. And in 2017, we launched the industry's first graph platform. So the graph platform, we have a number of components around the edge. So for example, we have got here in development and administration, we've got the Neo4j desktop, and that is the mission critical tool console for being able to manage your Neo4j licenses, what instances of the database are running, installing your key components such as the fantastic APOC libraries and algorithms. We have the data integration layer here. And there we've got, for example, the Neo4j ETL tool, which helps to reveal hidden relational database relationships as you're importing them into the graph. We've got a data importer for fast data ingestion, And as well, we've got connectors for Hive and Spark, amongst other things as well. We've also got on the side of graph analytics. Now, where the power of graphs really come into their own, because we've built all these connections up between the data, because we're connecting, looking at the relationships of friends, of items that people have bought and so forth, we can start to level powerful graph algorithms such as PageRank and centrality to understand any clusters, relationships, areas of investigation and so forth. And there are some really great YouTube talks and meetups that have been held by Neo4j. So I do suggest you check those out if you'd like to learn more. As well, on the discovery and visualization, we integrate with a lot of very popular visualization vendors. So from your Tableaus and your ClickViews to the graph-based ones such as Linkurious and Keylines. And also the Neo4j browser is really powerful for being able to pull together Cypher queries and interrogate your data, and then you start thinking about building custom visualizations on top of that to continue your graph exploration. And right in the center of it, the heart of it, is our current version of Neo4j 3.3, which is the powerhouse of the manage that. This is our native graph database where we have high-speed traversals of information, where we really start to see the power of what graph can do. And I'll touch on slightly a little bit later about how that setup means you get a faster performance when you're looking at connected data compared to relational databases. So just going to quickly cover some of the graph platform benefits. So we are used both in analytical workloads, which would be traditionally what people would see to use us, and in operational workloads, so the actual operational database for companies. So we have many companies looking to use us for real-time recommendations, real-time fraud detection, and so forth. Performance. Because of how we store the information, and very much visually as we described on the property graph model and describing how that works, how the nodes of information and the relationship between them are seen, that's how we store them to disk, which means when you're looking at how nodes relate to each other, you are literally running pointer to pointer, running node to node, rather than trying to figure out how these items connect together and do that processing before you interrogate. So it is really fast. Agility, and again, I'll touch on that briefly shortly, but you can have this really fast turnaround from design to delivery, because the modeling you're doing, your graph modeling, this is effectively the kind of language that you have with the business. And when they start talking about how customer may relate to account, how customer relates to an order and the products associated with the order, that level of information is how you model it and store it in the graph, which means you don't have to worry about the further steps of how you optimize your data for storage and so forth. So you get a really quick throughput from design to delivery. Discovery and visualization. Again, we touched on this. We have this powerful interactive browser that you can look through your model, and you can use a lot of the market available visualization tools as well to look at that. Developer productivity, again, we touched on that a bit. We've got the developer console, so we've got the desktop where you can manage the instances powerfully. And you've got Cypher, which is a really intuitive language. And again, as I mentioned, we'll look through that shortly, and you'll be able to see how intuitive it is to use. And we've got a huge community using it worldwide. And again, hardware efficiency, just by nature of how we store the data and how we retrieve it. It means it's very efficiently stored, very quick to use. It means you need a lot less hardware to be able to do the same kind of traversals that you do with Neo4j comparative to your traditional databases. And yeah, we have got a large pool of technologists in the graph space. So as we mentioned earlier, over 10 million downloads. We run many, many events, over 400 a year. And again, if you're interested in looking at some of the events, please do look at the Neo4j website or look at our meetup website to see if there's any events near you to attend. And we have got over 50,000 trained developers and professionals working in the graph space. So we've done some pretty cool stuff, and we've been involved in some pretty cool stuff. And there are 3 projects I'd like to point out, which I think are really exciting. So the first one is the ICRJ, the International Consortium of Investigative Journalism, where they did one of the biggest leaks ever, which was exploring various deeds happening through the Panama Papers. And this was made possible by being able to connect that information together within the Neo4j, and more recently, the Paradise Papers that have come around. NASA. Now, this is a really exciting project. So NASA maintains this huge relational database where they've stored lessons learned from various missions and experiments that they've done over decades. And they were struggling to find information for more recent exploits to understand how they've tackled projects in the past. And by using Neo4j, they've managed to cut significantly the amount of time they needed to find information. And thirdly, eBay, the knowledge graph. So they're working on creating this conversational bot where, for example, if you're looking for a brown handbag or a pair of purple trainers, you can put in there and talk to the chatbot, and the chatbot will figure out what you're after and then come back with relevant results. And again, that's extremely powerful, and it's showing how graph database can be used to build knowledge graphs and interactive, powerful knowledge graphs. And if you want to know more about these examples and how they were built and the process that were used, please do check out the Neo4j YouTube channel, and you'll be able to find talks by the various parties on there. So just to quickly touch upon a couple of ways that I mentioned earlier about why the graph database is so powerful and how it can speed up development, especially in comparison to your more traditional relational data sources. So very much when you're starting to have a conversation with the business, or you're looking what you're trying to model and the data you're trying to bring in, you start off typically with a whiteboard or a sheet of paper, and you start to think about what are the key components of information that you want to think about that are important to you. And then you start to think about the relationship between those data entities, and eventually at some point when you're asking questions later and you've built the solution, you need to think how to rejoin that. Now, a really powerful thing about graph databases, you put those relationships in straight away. They are first-class citizens along with the nodes of information that you're storing, and pretty much once you've understood and fleshed out that whiteboard model, that is what you're going to put into Neo4j. And that significantly speeds up development time without having to worry about how you're going to store the data, how you're going to normalize it, what's the best approach, and so forth. And that is a really powerful way of doing it. And it's easy to have a conversation with the business as you refine your work further on. Another bit I'd like to pull out is how you go about retrieving the information. So as we covered, when you're storing your nodes of information and the relationships between them, you write that information immediately to disk, comparative to a relational model where you're thinking about, certainly traditionally, how you'd have saved space, so you would have normalized that data. And when you're trying to read beyond a certain number of tables and you start to do those Cartesian joins, you get a big loss in performance. Whereas because you've stored that information as you intended the relationships to be with a graph database, it's extremely quick to traverse through because you've already written those joins at right time. So just to cover a few use cases. So Walmart, for example, one of the biggest retailers in the world. And one of the challenges they were trying to do, they were looking to optimize the user experience on the website. They wanted to improve how they did recommendations. And there are a number of ways to do recommendation engines, and the power of using a graph database is that you can leverage patterns. So context patterns, if people buy t-shirts and trainers and sunglasses, the context potentially is that they're going on holiday. So when people start doing that, start filling the basket in that way. You can start making recommendations. You can start to have a look at what people have done to buy things. And again, if somebody buys jeans, socks and a t-shirt and somebody else buys jeans, socks, you may start suggesting t-shirts and so forth. And being able to do that at real time and recognize what stock you've got available and so forth is really powerful. And having that in the graph means the traversals are so fast and finding those patterns are so fast, you can have this amazing real-time performance. So another client, eBay, so through one of the services they offered was this ability to be able to courier deliveries in a small time window. And the real challenge that they had was being able to figure out who's the best courier to deliver an item locally. And they were using a MySQL solution for that. And that would involve very complicated joins across tables and so forth. And again, it's having that problem of when you start having to have multiple Cartesian joins to get the information out, it gets very, very slow. They completely transformed how they went around this problem by introducing a graph database, because again, the joins are traversals, they're hops. It meant that the result that came out of that was significantly faster than the original solution they were using. And again, we've had some very impressive quotes from them working on that. And last but not least, again, a top-tier US retailer was struggling with transaction volumes around peak shopping occasions such as Thanksgiving and Cyber Monday. And they were struggling with some of the legacy infrastructure that they had. And they completely reinvented what they did through their promotion engines and so forth by bringing Neo4j into their network, where rather than, again, trying to do these big joins and trying to predict where they needed to have these big joins, they had all of this data connected up and they could quickly traverse the network through that. So we have a lot of big customers, as we've covered before, and we have many, many detailed use cases available on the Neo4j website. So if you want to find out more about them and the different areas that they've applied them in, such as master data management, access management, 360-degree of customer and so forth, please do check them out. So last but not least, I'm going to briefly cover Cypher, our querying language. And we're going to go back to Anne and Dan, as we mentioned earlier, and look at how we would perhaps create this relationship in the database. So you've got Anne here, and as we talked before, we have the nodes, and we're going to apply a label here of type person. So Anne's a person, Dan's a person. So we have the create keywords, we do a colon and add person, and that's effectively now saying that this node is going to be of type person, and this node here is also going to be of type person. We're also going to add some properties on here so that we can further refine what the nodes are. So we do this by adding the curly braces, and we do a key value pair type syntax. So here we've got name, Anne, brilliant, and then we do the same over here, name, Dan, and that's us having added the property. And last but not least, we want to understand the relationship between these two nodes. So effectively, we just do this arrow context. So the direction here, like I said earlier, that can be important if we want it to be important, and if we don't want it to be important, then when we come to query the information, we can forget about that. And then we just put in the type of relationship. So that's colon loves, and that is it. That will create the two nodes and the relationship between them, and we know what the nodes are. So let's add a little bit more in there. So we now want to represent or query the relationship between that. So to retrieve the information, so if we were keen to know the direction of a relationship, so we wanted to know, for example, let's say in this example, Anne sent a Facebook request sent a friend Facebook request to Dan, then we may want to know the direction because she's initiated that connection. So to retrieve information, we put in match for the keyword. We can put in the label. We don't need to put in the label, but it speeds things along. So we put in the label, type person. We put in the name Anne. We put in the relationship type. So it's Facebook friends, and the direction, and then Dan. That'll bring it up. But if we wanted to ask the question, well, actually, we just want to know, bring me back if Anne and Dan are friends, and it doesn't matter who initiated that connection, we just want to know whether they're friends, then same query, and we just drop off the arrow, and that will bring back that query. Let's try something a little bit more complicated. So, a social recommendation. So we've got Phil, and he's got a couple of friends. Phil's going to be staying in New York shortly, and he really likes sushi, and he wants to know what his friends would recommend. What restaurants would they recommend in New York? So let's have a look at the query. Very simple. So we're matching person is friends with friend, or is friend of friend. So that's effectively going to say, find me these two nodes where they're friends of friends. Now, find me friends like restaurant. So looking at these nodes there, they're looking at these two restaurants here. Find now, traversing even further, restaurant located in location. So these restaurants are now connected to a location, and restaurant serves type cuisine. So again, multiple relationships, they're connected to a type of cuisine. Now we start putting the filters in to make it more specific. So we've got the pattern here, and now we're telling it where to pinpoint. So person name, Philip, there we go. Location for where he's going, New York's here. Type of cuisine, sushi. Return the restaurant names. So if we plug all of that into this model, it will bring back this restaurant here and this restaurant here, the names. Simple as that. And as you can see from this, it is a really intuitive, human readable language. And it's such a great language. We made it open source in 2015, and it is seeing great adoption. And it's really popular. If you're interested in finding more about OpenCypher, again, do check out the OpenCypher website. That's opencypher.org. And it's being used by a lot of customers and, being used by a lot of competitors as well. So do check it out of interest. Really powerful language. So where can you learn more? Well, as I've mentioned, you've got the various meetups, and you've got anything from learning about graph data modeling to understanding more about graph databases to more about doing various graph algorithms to them, to webinars as well. But also we've got GraphTour coming out this year. We've got the European cities listed out there, and we've got the US cities coming out later in the year. It's a free event. You'll have an opportunity to talk to lots of experts and do the graph clinics at the tours and hear what our customers have to say about the product. And again, if this is interest to you and you'd like to register, and please do check it out on the website neo4j.com/graphtours. So thank you very much for your attention, and if you have any questions.
Yeah, thank you so much, Lou. That was great. So to kick us off, we have a question here on what is kind of the advantage of Neo4j's database over MongoDB or RDBMS?
So the powerful thing with the Neo4j comparative to, say, MongoDB, and again, it is about the application that you're doing, but it's a lot easier to build in the connections within your data. So it's a lot more intuitive in the sense that when you identify your nodes of information and building relationships, that is straightforward, and you do that at right time when you're building them in. And certainly, as we covered with relational databases, the having to connect your information back up at right time, especially when you've got multiple joins across tables, can be very slow in comparison to Neo4j, where it can take milliseconds to bring back equivalent queries.
Okay, lovely.
Right.
And more on the import side. So when you're dealing with a CSV file importation, how would you create or define relationships between nodes after importing the CSV file into Neo4j?
Right, so typically what you do when you're importing data from a CSV, where you define the query. So I don't have a sample here, but it's very well documented, certainly on the website. But effectively what you do, you will at the time of creation, so if we come back to our example here with Dan and Anne, you would effectively have a reference for each column that you've got in your CSV, and then basically make a reference to that and then state what the relationship will be. So yeah, it's relatively straightforward in that sense. You define the relationship at point of import, and then you can also tweak it slightly. So if you've got nodes that need multiple relationships from the CSV, then you can re-ingest the CSV to do that, and so forth. So again, I do recommend check out the documentation on the website. It's well described.
And a quick one, do we have any clusters set up for Neo4j databases?
Yes, so with the enterprise edition of Neo4j, we do have what we call causal clustering. So that provides high availability and data redundancy. So you can do that from multiple geolocations or how you see fit. So yes, that is available.
And would it be easy to change the structures of the graph as you go, for instance, adding relationships or evolving the schema?
Absolutely. So it's very powerful with how you can add and remove relationships. So what you can do, so say for example in this relationship here, Anne no longer loves Dan. It's unfortunate, it happens. So what we can do here is we would effectively match the nodes, either one of these points, so Anne and Dan, and then we would remove that relationship. So if we wanted to, so we could either remove the relationship completely, or what we could do is find Anne and Dan with that relationship, and we could change that relationship from loves to hates. So that is very easy, very straightforward within the product.
And I guess a bit of a follow-up to that, so is it possible to have the same relationship in both directions?
So if you wanted to, you could, and I think we have that at the start. So you could have a relationship in both directions, and so as we got here, we've got person loves person, and in the opposite direction, person loves person. So you can do that, and if there is a need for it in your use case, absolutely you can do that. But as I said before, the relationship is important as you need it. Well, the direction of the relationship is as important as you need it to be. So if it's essential to represent the bi-directionalness of a relationship, then absolutely that is a way you can do it.
Do you have to match data by tag label, and how could you do that?
Right. So the labels are not mandatory. So if you want to put a label on to tag an object, you can. If you, actually no, I think double check. But with labels, when you're querying, you don't have to include a label to query. So let's say, for example, I don't know, you're doing some kind of fraud detection and you don't know whether the person you're looking to investigate is a customer or a employee or so forth, but you've got a name and you're not entirely sure whether actually that's a person or a legal entity or something like that, then you can skip the label off completely and just search based on properties, or you can search based on a pattern on some nodes and relationships. So you don't have to use the label for querying.
Lovely. And I think we have time for just one or two more. I know we're a little bit over. Let's see here. So you mentioned quite a bit about Cypher. Do you need to download any software to start querying with Cypher, or what's kind of the best way to get started there or get using it?
So when you download Neo4j and get it set up on your machine, Cypher is an integral part of the product. So you have a number of ways of how you can use Cypher. So you can either use it via the shell, via the drivers that we have available, but also via the browser. And effectively what happens is when you get Neo4j up and running, the engine running, then you effectively just go into your favorite browser and connect to the database via that, and then straight away you can use Cypher. So it's an integral part of the product. It's there. You don't have to do anything special to get it installed.
Okay, great. Sounds pretty quick and easy. So I think that's really all the time we have today. We did get quite a few questions, so thank you for those who participated. I'll do my best to send out a few emails with your responses. And again, keep an eye out on the email address that you used to register for today's webinar. We'll be sending you a few follow-up links if you want to get started with Neo4j, learn some more, and as well as the recording from today. So thank you very much again, Lju, and enjoy the rest of your day, everybody.